Hey guys, welcome to Saturday's problem, day 3 is it, of lockdown. I thought this meme would be appropriate to start the day. Schools are closed, essential services only. I'm an essential service, calculus is an essential subject. So, we're going to look at a past scholarship exam question today, and we're going to look at 2 different ways of solving it. It's from the 2015 exam. Okay, so here's the problem. It looks like an absolute mess on the left-hand side. A mixture of double angles and single angles, and on the right side it looks real tidy. The denominator has a common factor, suggesting there's going to be some factorizing going on. I would say start on the left because there's more to simplify. Alright, solution time. Hopefully you've had a go at it and hopefully you've been successful. We're going to look at 2 solutions. The first one's quite long, so just stick with me. That was a pun because the PowerPoint presentation here looks like a whole heap of post-it notes. In fact, the hoodie that I'm wearing is a bit of a pun. If you can see the logo on it and you can understand the mathematical play on words there, then maybe send me an email and you can win the daily prize. Alrighty, left-hand side. That's pretty fancy. Like I said, got double angles and single angles. Let's get all into the single angles. It's easier to go from double angles to single angles. There's heaps of formulas for cosine 2x that reduce down to x's. It's harder to go the other way around. If you want to go from x's to 2x's on the formula sheet, you would need to rearrange those double angle formulas, and it can be a bit messy. So generally, if a problem has double angles, you can reduce them down quite easily. Change the cosine 2x to, I chose that one, but there's 3 of them you could choose from. Expand that out. You're going to get a whole heap of cosine squared, sine squared terms. We're going to get rid of all the sine squared terms. Notice that there's shifts in the denominator in line 1. Cosine of 5 pi over 2 minus x is just the same as sine x. You just graph it on the calculator and have a look at it. Use your technology to your advantage. Be careful though, it is being squared, so we still have a squared there. Similarly, the denominator, the bottom right of the denominator, sine squared of 2 times x minus pi. That x minus pi shifting to the right by pi, actually does nothing because of the frequency 2. Sine of 2x minus pi is the same as sine of 2x. And then sine of 2x is the last double angle to get rid of. Sine of 2x is 2 sine x cosine x, being squared, therefore we have the 4 at the bottom. All right. Changing all the sine squared bits to 1 minus cosine squared so we can get into some like terms. Expand all those brackets out. Play around with all the like terms, put them together. Denominator, we still add a sine squared. Goes with the 1 minus cosine squared to become 1 minus cosine squared squared. Told you it was going to be a bit of a mess. Now, we're at this stage. We kind of knew there's going to be a factorization. It's actually a disguised quadratic. 16u to the power of 2, if you make u cosine squared, minus 23u plus 7. That factorizes, no doubt, into that. Common factor cancel. And then this is a little bit messy, but we changed the 16 cosine squared bit back into double angles. Now, this seems a little bit counterintuitive because the right-hand side was double angles. We got rid of the double angles first so we could put stuff together and simplify it. But if we do that, cosine squared minus 1 is just this. Cosine 2x plus 1 over 2 is the rearranged version of cosine squared x. And then times the whole thing through by a number and we'll get that. Boom. Right-hand side. And the smiley face. Where's my full stop gone on my exclamation mark? Okay, an alternative method. I'm just going to post this here for you and you can have a look at it. I'm running out of time. 5 minutes of recording time and I've got 4% of battery left. Some things don't change. Again, as you see, this method is a lot quicker. An extension from this, could you start on the right-hand side? And I mean, don't just look at the working and go backwards because that's cheating, but could you start on the right-hand side and manipulate it to get the left? I'll see you tomorrow.